Once again, this is Harold Waters with OSU Extension, a field specialist for agronomic systems. This is my third set for the nitrogen management series. So how do we determine the correct nitrogen rate? I talked just previous set about using the MRTN, the maximum return to nitrogen, that corn nitrogen rate calculator. This time we'll talk about tools you might use for predicting that crop need. So what are some tools that are out there, some other recommendation tools? Cornell University has a web-based, an application-based product they call AdaptIn. Now is actually is a private company set up just outside of Cornell University. But they use field-specific weather conditions for your site. And the idea is that they would be able to give you through the season recommendations on how much or nitrogen to apply or how, when not to apply. Climate Corporation, now owned by Monsanto, also has a nitrogen advisor. Again, they used information from remote sources, satellite, rainfall records, things like that. Pioneer has a tool they call Encirca, which has a nitrogen management service. As part of that, you pay a fee to a local advisor, and then they use, again, some web-based and satellite-based information, rainfall records, things like that, as well as soil information to put together a recommendation for you. And then there are a number of soil tests out there, the Haney H3, Solvita. Some of these are soil quality tests, and the goal is that they can determine your soil quality, and that would give you some indication of how much nitrogen you might apply. Those don't always go hand in hand, and there is some concern about the use of those tools. Those concerns might be that they're not quite ready yet, but I think it's something we need to think about. And then there are more services, perhaps a consultant, and then there are different kinds of applicators, some that lay the nitrogen very close to the corn stalk so that it becomes available for taken up quickly. And then there's also applicators that may be able to apply later in the season, giving you more flexibility on application. There's some notes here I'll run quickly through from Purdue University, Jim Camerato and Bob Nielsen. I kind of like how they put some of these thoughts together. So they thought there are some ways to improve nitrogen management. The pre-sidedress nitrate test might be one tool perhaps to think about. And in a livestock situation for nerd fields, this has more value than we've been taking advantage of here in Ohio. So something to think about there. There's also an end-of-season stalk nitrate test, which can give you a report at the end of the season whether or not you overapplied or underapplied your nitrogen. There's also in-crop sensors, and I'll talk a little bit more about that. Some work's done here in Ohio as well. But this would be the use of optical sensors to kind of make some comparisons between a high nitrogen reference strip and areas of the field that have not yet had nitrogen applied. Be able to use that information to develop a recommendation. So the PSNT, the pre-sidedress nitrate test, here again some remarks from Purdue University. Number one, greatest value in a livestock system, and in a quote here from Robert Mullen, I believe it is, this test is of little value when there is no manure in the system. So the attempts that have been used to use it in a corn, soybean, simple grain system have not worked out that well in Ohio or Indiana for that matter. But where we have manure, good tool to use. So how do we sample? A 12-inch deep soil sample when the corn is 6 to 12 inches tall, perhaps in a 4 to 6 inch leaf stage. And what we do is we can get a reading shown here on the left, and we can use that information from that soil test at sidedress time to reduce the amount of nitrogen we might apply to fill in the rest of the season. The Purdue stalk nitrate test, again, a chart here showing some of that information, and again, showing the reading on the left. We might be able to use that information to determine whether or not we have had adequate amounts of nitrogen. Again, it's a report card. It shows us information at the end of the season that we might use to make recommendation changes for the next year. Their recommendations are to use this for 3 to 4 years before we start making changes. And then remote sensing. Benefits of remote sensing. It allows us to postpone our decision until after emergence. That nitrogen we put on at the start of the season is more at risk to loss than the nitrogen we put on mid-season. So the idea would be we'd use a tool to base our nitrogen recommendation on as we get farther in the season. And then the expectation would also be that we can reduce that nitrogen rate and allow the contribution from our soil mineralization to allow us to know how much nitrogen we may have already made from this growing season, and then reduce our nitrogen for that application that we might make as side dress. Here's some work from Peter Scarf, and just a quick summary here. But he's done some work across 66 regional experiments, so not just Missouri, but some other Corn Belt states, and found that they can use a in-crop sensor to improve the accuracy, maybe to 50 to 67%. May not sound all that great, but that's way better than what farmers have done with their pull it out of the back pocket kind of a recommendation. So it is an improvement. I think with time, with some delay in readings, some of the farmers were a bit anxious, and so would take readings at 2 to 4, V2, V4, things like that. We really need to wait to after V6 to take these sensor readings, and with that we can make some improvements in our recommendations. Here's some an overview of some trials that Robert Mullen conducted. These were from 2006 through 2009 at 3 locations, so these are research farms in Ohio. And what he found was that they could make an improvement, a reduction, maybe in our nitrogen rates. The in column there in red, where it says sensor rate in pounds per acre, this is what the sensor told us to apply with our information that we were able to gather from the plots. So we applied on average 130 pounds of nitrogen per acre. And so there was some yield reduction compared to the our control, which is our high nitrogen rate that we use for a reference strip. And you can see that, yeah, generally here we may have yielded a little bit less per acre, but our income per acre was equal, perhaps a little bit better under the best conditions than what we might get with that, putting on that full amount of nitrogen. And then the key point here is 200 pounds of nitrogen versus 130. That's 70 pounds of nitrogen that may have been saved from a loss, from that field. Think of it in those terms. Do point out here some management requirements. We do need a high nitrogen rate strip for comparison, so we can make that determination of what the crop should look like versus the other. And then we would use an algorithm to determine our nitrogen recommendation, and we have that set for Ohio. So how can we reduce the risk of nitrogen loss? I think our first goal should be to start with the application of that MRTN rate, that corn nitrogen rate calculator rate. And again, the Iowa State University's website here for that online calculator is available. I would also make the suggestion we make no surface application of nitrogen. Incorporate it, band it, inject it, whatever it may take, but get it below the surface. Again, some risk shortly after application. Delay the application, maybe apply 30 to 60 pounds of nitrogen at planting, side dress the remainder. Again, if we can delay that application, we reduce the risk of loss. One suggestion I had from a young man, and I thought this was a good idea, so I'll repeat it here. His thought was supply 100 pounds of nitrogen as anhydrous ammonia before planting, and then use a crop sensor in season to apply the difference that he may need. And in some areas of the field, he may need nothing. Some areas he may need as much as an additional 60 to 100 pounds of nitrogen. But by using that tool, he could determine later in the season how much more nitrogen he might put on. He would still have his base layer down, and for many areas of the field, that 100 pounds of nitrogen may well be enough. But this would allow him with that tool to go in and make a recommendation to make some changes after the crop got growing. Rotate crops. Of course, corn after soybeans uses about 40 pounds less nitrogen. And if you're using manure, use that nitrogen source as well as phosphorus, in your determination on what your crop nitrogen need may be. And then also consider a grass cover crop. At the end of the season, we can capture some excess nitrogen, hold it in place in tissue, and not let it get lost to the environment. So bottom line on reducing nitrogen loss, we have to reduce the nitrogen rate, but that means we need to find a tool that works for us that lets us get closer to the right rate in the first place, because we don't want to lose yield. So what that means, apply nitrogen when the crop needs it, Don't waste nitrogen by applying a surface, and that's a risk of waste, I'll admit, but don't necessarily take that risk. Put some on early and then reserve the remainder for delayed application. And some say put on no more than 50% of what you believe your nitrogen rate may be. So again, in that 30 to 60 pounds of nitrogen perhaps. Use a tool, and I'm going to say here, try some tools. I don't know what the best one is yet. I lean myself toward the in-crop sensors, but there are some others out there. So there's some models, there's systems, there's sensors. Whatever you may enjoy or whatever may do the best for you in your operation. But find that tool that helps you tell how much the crop needs in mid-season. And then for reducing nitrogen loss, I think technology is going to be the answer in the form of managing more and more data. We probably need, I've been told, perhaps 6 to 7 layers of information to make that right nitrogen rate application recommendation. So there, we need to think about how we manage that big data. And also, I think there's a potential in farm genetics. We're not there yet with having a corn hybrid that will make its own nitrogen, but we are moving in a direction to improve the efficiency of that system to either operate on less nitrogen or be able to take up nitrogen in a better way. And so, generally speaking, we're going to have to reduce the nitrogen rate, but at the same time, we need to find that tool that helps us produce our best crop with that lower nitrogen rate.